Hi, it's Miss Logan. Today I will be discussing work, kinetic energy, and power. Why did it do that? So how do I define work? Well, it's not the work that I'm talking about in Rihanna's song, Work, 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 which I was going to play, but then I thought about copyright infringement. We're talking about physics work. So work equals force times distance. So we're talking about work in physics. So work equals force times distance. Force is in newtons and distance is in meters. Now this is actually defined as work equals force times distance times cosine theta. So if I have a situation where something is going up an incline or down an incline, I'm going to use this version of the equation. Now, once again, a work is force times distance. Now, what are my units here? Well, I have newtons times meters. And this is what we call a joule. So this is the unit that we're going to use for both work, and we'll see in a moment that we use for energy. But let's break this down one more time. So what is a newton? Well, force equals mass times acceleration. So a newton would have to be kilograms times meters over seconds squared. Now, let's keep that in mind as we go on and talk a little bit more about how we can define work. Now, work and energy are actually the same thing. So work is the way that we can actually relate force to energy. So my total work is equal to delta K. So K is my kinetic energy. Okay. Kinetic energy is one of my multiple forms of energy that we'll see this unit. So how do we define K? K is 1/2 mv squared. Now, you might be wondering what units I'm going to use. Well, for mass, I use kilograms. And then for velocity squared, I have meter squared over second squared. Now, as a reminder, work equals force times distance from the previous slide, which is kilograms, meters over second squared times meters. Remember, I get this from F equals ma. So if I look at this, I actually have the same exact unit. So for both work and energy, I have the same unit, which is a joule. So I have my kinetic energy, K equals 1/2 mv squared. Now a variable force is something that is changing. So the amount of force could change. So this is something like a spring and a block that's being compressed. So for this, my work is equal to 1/2 kx squared. So K is my constant, like my spring constant, and x is the distance that it is compressed, and that is in meters. So as you can see, these two, and not by coincidence, are very, very similar in the way that they look. Now let's look at a problem. So a spring with a spring constant of 475 newtons per meter is compressed and releases a block of 1.5 kilograms with initial speed of 2.2 meters per second. So let's look at this. So I have a spring, and then I have a block, okay? And for this problem, I am looking for delta x, or x. So remember, in the equation, it is x, but it's good to think about delta x. It's the amount that is being compressed, okay? So let's think about this. I have my kinetic energy is 1/2 mv squared. So I have 1/2 times 1.5 times 2.2 squared. So initially, that is my kinetic energy. So that's going to give me, when I multiply that whole thing out, 3.6 joules. Now, I know that to figure out my compression, I need to use my work equals 1/2 kx squared. Now, if we think about this situation, my total energy the whole time is going to be 3.6 joules. So I have 3.6 equals 1/2 k, which was given, and x squared. So from here, and I encourage you to take a minute to go through the steps, for x, I'm going to get 0.12 meters. So, important note, and this is really something that we'll talk about next flipped lesson, but the energy that I have during anything that's going on is going to be the same at the beginning and the end. It's going to help branch those two. So, our next thing that we're going to talk about is power. So, power equals work over time. So this is the amount of work that we're doing over a period of time, and this time is in seconds. Now, as a reminder, work is force times distance over time. Let's derive actually a second equation. Distance over time, take a minute to think about that. What does that give me? That's velocity. So power also equals force times velocity. So in power, we're looking at the amount of force and distance we did over a certain time. All right, so make sure you have your notes. In class, we will be practicing working with labs for these concepts.